Alright, this is your Ellipses Part 2 video. Alright, so today we're going to talk about the focus points, or plural, foci. Alright, remember yesterday when I said you have 2 points where you can put thumbtacks, tie a string around, and then use your pencil, and as long as you keep the string taut, you will draw a perfect ellipse? Well, the location of those 2 thumbtacks would be your focus points. Alright, they would be your focus points. Then the distance from the center to either focus point is called C. Alright, so C is the focus distance. It's the distance from the center to either focus point. And to find C, it's the absolute value, it's the square root of the absolute value of a squared minus b squared. Alright? That's how you find C. So now in this example, when your ellipse is going left to right, to find these focus points, you would take your center, and it would be h minus c, k. Remember, hk is your center point? So hk would give you this point. So to find this focus point, you'd do h minus c, and to find this focus point, you do h plus c and k. Alright? Because if it's going left-right, both focus points will have the same y value, and then your x value will be h minus c for this one and h plus c for that one. Now, if it's going up-down, alright, if it's going up-down, this would be h, comma, k plus c, and this one down here would be h, comma, k minus c. So that's how you find the coordinates of your foci, right, of your focus points. You have your center, which you can get from your equation. Remember, it's h and k. So when your ellipse is oriented up-down, you simply add c to the k value, and that gives you your upper focus point. Subtract c from k, that gives you your lower focus point. And when your ellipse is going right to left, you subtract c from h to get your left-hand focus point, and to get your right-hand focus point, you simply add c to h. And again, the formula to find c, it's the square root of the absolute value of a squared minus b squared. Alright, so let's work a problem. We're going to find the foci of an ellipse given only the equation. Alright, so here's our equation, and we want to find the foci, or the focus points. X minus 1 squared over 25 plus y plus 2 squared over 9 equals 1. Alright, first thing first, you have to find the center of the ellipse first. So, x minus 1, 1, y plus 2, negative 2. There. We found our center point. Now we need to know what is the ellipse direction. Meaning, does it go left-right, so is it laying over sideways, or does it go up-down? Well, what you do is you look at remember, this would be a squared, so this is 5 squared. This is b squared, so this would be 3 squared. Since x is larger, your a value is physically larger, that means that our ellipse goes left-right. It's an R. Alright, that means our ellipse goes left-right because x is larger, so it's longer this way than it is tall. Now, we got to find c. Remember, it's the absolute value of a squared minus b squared. So it's the absolute value of 25 minus 9. So 25 minus 9 is 16. It's the square root of 16, which is 4. So now, find the foci. Alright, we know it's left-right. So I'm going to say f sub 1 for the first foci and f sub 2 for the second foci. Alright? So, if you remember, when it goes left-right, your y values are going to be the same as your center point. So both of these are going to be -2. Now, to find your leftmost focus point, you're going to subtract C from H. So we're going to do 1 minus 4. So our leftmost focus point is -3, -2. And our rightmost, we're going to add C to our X value. Alright, so focus, this is our left focus point, and this is our right focus point. Okay, so first thing you want to do, you get your equation, find your center, find the ellipse direction. Whichever one of these is bigger. If this one's bigger, it's left-right. If this one's bigger, it's up-down. Alright, so we determined that ours is left-right because a squared is bigger. Now that we know that, we found our C, which is the square root of the absolute value of 25 minus 9. That was 16, so 4. So we know that it's left-right. Our y values are going to be the same as our center point. And for our x values, we simply take 1 and subtract 4 to get our left one. 1 plus 4 to get our right one. Alright. Let's look at one more example, and then we're going to get into something called eccentricity. Big word, easy to find. Don't worry. Alright, so find the foci. Find the foci. So first find the center. Well, I guess it helps give you the equation. Alright, there's the equation. So first find the center. Take a moment, what's the center? Hopefully you said 3 and -4. Alright, direction. Is it up, down, or left, right? Hopefully you said up, down. Because y is bigger, b squared is bigger, it's up, down. Now let's find C. C is the absolute value of 4 minus 64. So square root is 60. 4, 7.7. So now let's find our foci, f sub 1. Remember, since it's up, down, means our x value of our center point and our foci are going to be the same. So f sub 1 and f sub 2 are both going to have an x value of 3. Now, here's what we can do. We can do this. We can either do -4 and then we can do plus the square root of 60 and minus the square root of 60. So we can do it that way, or we can put in 7.7 for the square root of 60 and say 3, 3.7 and then 3, -11.7. I would take either one of these as your correct answer. I would take either one as the correct answer. Alright? So you just find C, and then you simply add and subtract it from either your x or your y, depending on the orientation of the ellipse. Alright? Now let's go into eccentricity. Remember, big word for something easy to find. And I usually abbreviate it ECC, but I'm going to write it out so you know how it's spelled. Eccentricity. It's the measure of how squished the ellipse is, or an ellipse is. Alright? Apparently I can't keep the line up. Alright, so it's the measure of how squished the ellipse is. You're either going to see it abbreviated E or ECC. Now, this is the important part. It is a number between, a number between 0 and 1. If your eccentricity of an ellipse were 0, you would have a perfect circle. And if your eccentricity were 1, you would have a straight line. Alright? So if your eccentricity were 0, you'd have a perfect circle. 1, you'd have an absolute straight line. So the closer to 0, the more your ellipse is going to look like a circle. The closer you get to 1, the more stretched out it's going to be. Alright? Now, let's go over your formula for eccentricity. So your formula, it's really complicated. Just kidding. Formula, your eccentricity equals C divided by A or B. Now, to tell which one, either A or B, it's whichever is biggest. Alright? So if A is bigger, it's C over A. If B is bigger, it's C divided by B. Whichever one is bigger is what you divide by. Alright? Whichever one is bigger is what you divide by. So let's look at a problem real quick. And all we want to do is find the eccentricity. Alright, all we want to do is find the eccentricity. So the first thing we have to do is we have to find C. Alright, we have to find C. Well, I did this problem earlier, and if you remember, earlier C equaled 4. This is the very first equation I did. If you remember, C was 4. So now, for our eccentricity, we're going to take 4 and divide it by the bigger one of these. But remember, it's A or B, and this is A squared and B squared. Alright? Well, here, this would be 3 squared, so B is 3. This would be 5 squared, so A is 5. A is bigger, so C equals 4 divided by 8. Wait, why did I put 8? Oh, I know why I put 8. 4 divided by 5, which is 0.8. That's why I put the 8. I put the 8 in the wrong place. Alright? So, our eccentricity, is 4/5, which equals 0.8. Alright? Because remember, C, you have to find C. It's the square root of the absolute value of A squared minus B squared. Alright? And then it's C divided by the bigger one of these. And remember, if this is not written in the form of a number squared, you need to take the square root of this first. Alright, so A is 5, B is 3, A is bigger, 4/5 or 0.8 is your eccentricity. Alright. Let's do one more if the camera holds out, because the battery's getting low. Alright. So I want you to find the eccentricity. Alright, find the eccentricity. You have x minus 3 squared over 4 plus y plus 4 squared over 64 equals 1. Go, find the eccentricity. Alright, well hopefully you recognize this problem as from an earlier problem. So we know that C was either the square root of 60 or 7.7. Alright, so I'm going to write it both ways. We have the square root of 60 over, or the 7.7 over. I'm going to write it both ways, so depending on which way you wrote it, you can make sure you got it correct. Now, which one of these is bigger? Well, A is 2 because that's 2 squared, and B is 8 because that's 8 squared. 8 is the bigger number, so we're going to be dividing by 8. So there's your eccentricity. You can either say the square root of 60 over 8, or you can give me 7.7 divided by 8. So as you can see, this is really close to 1. So this ellipse is going to be really, really skinny. Alright? Because it's pretty close to 1. So it's going to be really, really skinny. Alright? So that has been your ellipses part 2. Make sure you know the formulas. Make sure you know how to find C, the eccentricity, your focus points. Make sure you know how to find all that. You can watch this as many times as you need to. And make sure when you come to class tomorrow, you're ready to work some problems. See you tomorrow.